All right, so we're back, right? Let's look again. Let's try and start making some rules for how to make our covalent Lewis structures. The first thing that we want to do is we want to count our valence electrons. Okay? Once we count our valence electrons, that's going to tell us how many total electrons we can have on there, okay? Including our lone pair dots and our single, double, or triple bonds, okay? The second thing that we're going to do, right, once we've counted our valence electrons, we're going to build a skeleton. It's perfect that it is Halloween this week because we're going to build a skeleton, right? So once we build that skeleton, what we want to do, we want hydrogen on the outside, because hydrogen generally, right, hydrogen can only share 2 electrons, so it's generally only going to be able to make a single bond. It's only going to be on the outside. We also, our halogens generally like to be on the outside. Not always, but they generally like to be on the outside as well. So let's look at CCl4 there. CCl4, right, we've got carbon that will have 1, 2, 3, 4 valence electrons, plus chlorine, I'm only going to draw one of them, 1, 2, 3, 4, 5, 6, 7 electrons, because chlorine is in column 17, so it's got 7 valence electrons. So we're going to add, right, this would be 4 times that, so 4 times 7, so that would be 28 plus 4 would be 32 electrons that we're going to put on here. So let's start and build our skeleton, right? Halogens like to be on the outside. We also know that carbon likes to be on the inside. Okay? Carbon always likes to have 4 bonds, if possible. Okay? So let's put carbon in the center, and let's give a chlorine onto each side. If we do that, that's 2, 4, 6, 8 electrons that we've accounted for, so we would have 24 electrons left. Carbon has 2, 4, 6, 8 electrons that are around it, so carbon doesn't want any more electrons, right? Once we build our skeleton, now we are going to put our electrons on the most electronegative elements first. So give electrons to most electronegative first. Okay? So our most electronegative element is chlorine here. So 1, 2, 3, 4, 5, 6. 6 lone pair electrons, so 3 lone pairs for chlorine, plus 2 more. That's 8 electrons around chlorine. It's stabilized. 1, 2, 3, 4, 5, 6. 8 electrons around it. It's stabilized. Right? Now I've got 1, 2, 3, 4, 5, 6, plus 2 more in the bond. 8 electrons around it. It's stabilized. Let's count how many electrons I have left. 2, 4, 6, 8 in the bonds. 10, 12, 14, 16, 18, 20, 22, 24, 26. I've got 6 electrons left. That's perfect for this last chlorine to have 6 electrons in the lone pairs and 2 more in that bond. So that then is going to give me 8 electrons around chlorine, and this is going to stabilize our element, okay? So once we give electrons to our most electronegative first, sometimes we're going to start having some more complex things happen, okay? So what we'll do is we are going to switch over to this packet here, okay? So this packet, there we go, this packet is what we're going to fill in throughout, okay? So we're going to fill it in over the next couple of days, right? Our first part, this should be our relatively easy ones, kind of similar to what we've done so far. Our next column here, these have our polyatomic ions. Our polyatomic ions we've started to talk about. These polyatomics are covalently bonded, but they have an ionic charge. Okay? So in PO4 3 minus here, right? This would be phosphate. Phosphorus would have 5 electrons plus 4 times 6 for oxygen, right? Plus 3 more electrons, right? Now we're going to go through and we're going to do the exact same thing that we've done, but we now have our number of electrons. We have more electrons because of the charge here, okay? And we also know that phosphorus is going to be on the inside of when we build our skeleton, because phosphorus is listed first here. Take a guess as to what element is going to be on the inside here, because it's listed first, right? This is why we said halogens generally like to be on the outside, but not always. Let's look now at our multiple bonds section, okay? For our multiple bonds, when do we get to start making double and triple bonds, right? And that's going to come into play with number 4 here, right? If we can't make an octet, now we share. Okay? So we did that actually up here with our nitrogen, right? Our N2. N2, we said, right, we didn't have enough electrons on this nitrogen, and it said, hey, let's share. So it shares with this other nitrogen, and then it shares 2 more, and overall we get a triple bond here to show that we are sharing a triple, or 6 electrons, okay? The last piece, right, if we can't make an octet, then we share. That only happens if we can't make an octet, okay? That's when we make our multiple bonds. We also are going to have some incomplete octets and expanded octets and multiple central atoms. Whoa, that gets complicated. We'll go through this in another video, okay?